Today we're going to be talking about two types of precipitation processes as well as different types of precipitation. All precipitation is formed from one of two processes. First one is collision coalescence, in which droplets larger than 20 micrometers will collide with one another, forming larger droplets which will coalesce and fall to the ground even faster. During aggregation, ice crystals will grow as supercooled water freezes to them. The ice crystals will then drift through the cloud and find other ice crystals, connect to them, and fall to the ground. Some different types of precipitation are rain. Rain is just water droplets that fall to the ground. It has a subcategory of freezing rain, in which water droplets will fall to the ground and freeze once they hit the ground. Sleet, the water droplets will freeze before they hit the ground. And in snow, ice crystals will form in below freezing atmosphere. They then fall in an environment that is also below freezing. And hail is formed from updraft in a cloud. The droplets are taken upward in the draft and collide with one another, and they form hailstones. So today we're going to be talking about four types of fronts. First one we'll be talking about is a cold front. During a cold front, cold air mass pushes into a warm air mass. This is what it looks like. See, the cold air is forcing the warm air up. The weather during this kind of front is gusty wind, drops in temperatures, and heavy rains or storms. The second front we were talking about is a warm front. During a warm front, warm air mass pushes into cold air mass. So you can see here, the cold air is here, the warm air is pushing up against the cold air. The weather during this kind of front is low clouds, rain, and thunderstorms. The third type of front we were talking about is a stationary front. During a stationary front, cold or warm front stops moving. As you can see here, these two fronts are kind of at a standstill. The weather during this kind of front is cloudy with rain or snow. The last kind of front we were talking about is an occluded front. During an occluded front, a warm front will push into a cold air mass, and at the same time, a cold front will push into a warm air mass. These will join together and become an occluded front. The weather during this kind of front is some precipitation, wind direction change, and a sudden drop in temperature. It either warms or cools. Usually, during an occluded front, a cold front will move faster, and the cold front is more likely to overtake the warm front. Okay, that's it.
Very nice.
Do you think that one's okay? Stop. Today we're going to be talking about airlifting. Airlifting is very important to the formation of clouds and rain. There are two processes of airlifting that we're going to be talking about today. One of them is orographic lifting. This is where air is forced over a mountainous barrier. Usually has moist air going up the mountain and cooler air going down. The precipitation usually falls on the moist air side of the mountain. Then there is frontal wedging, in which masses of warm and cold air collide. The cool, dense air acts as a barrier and matches the mountainous barrier, and it forces the warm air to rise. And you can see here, cold air acts as a barrier, forcing the warm air up, cooling it down, which eventually involves precipitation.